Oh, hello. You've just caught me as I'm about to plan this A-level chemistry lesson. We're looking at thermodynamics. In other words, does a reaction happen? And one of the endpoints of this unit is this equation, delta G equals delta H minus T delta S. We're looking at delta H, the enthalpy change at the moment. There's a couple of ways of working this out, either through a model or using what's called the Born-Haber cycle, which is what we're looking at in this kind of couple of lessons. All right. So to think about the consolidation, first of all, to consolidate, I'm going to get my students to do this exam question from 2023. It's got a Born-Haber cycle that they need to fill in and also a calculation that they need to do using these numbers. So I'm going to put that in as my consolidation because I feel like that's a nice thing for them to get to at the end of this couple of lessons. So calcium chloride Born-Haber cycle from the 2023 paper. Great, in it goes. So now I'm going to start working back and look at the demonstration. What I want to do here is give my students plenty of practice to do before they get to this consolidation. And in some cases, I'm going to actually make the practice harder than the question itself. I'm going to use this equation to help me think about my demonstration. Challenge is proportional to task complexity divided by support, right? So to kind of challenge all of my students, I'm going to think about ways of making this a little bit harder. So I'm going to choose a harder compound, aluminium oxide, as kind of one layer here, and I'm going to take away the support that this question is giving them in the exam, perhaps, right? Then I'm going to think about maybe like a middle layer. So here I'm going to give them something like sodium chloride, NaCl, and maybe just give them a little bit of support, maybe something like 2 lines. And then finally, a good kind of jumping off point for my demonstration would be something that hopefully everybody could access quite nicely, maybe magnesium chloride, and give them, let's say, 4 lines of support. Great, so now I'm going to think backwards again and think about the activation, how I'm going to get my students to be able to demonstrate all of this that I've been talking about. Well, there's 2 ways of thinking about this, really, for me. I'm thinking about my Born-Haber cycle and this kind of this concept, and there's 2 aspects to it. There's this knowledge aspect and there's also the process aspect, and that kind of really tells me about how my activation is going to look. For the knowledge bit, what I really want to do here is cognitively break down some of the kind of definitions that help them understand what one of these things actually means. So with that in mind, I think for my activation, I'm going to do a little bit of modelling where I'm talking to them about, okay, what does it mean when we talk about, let's say, the enthalpy of atomization? In other words, when I'm turning a mole of a substance into a mole of a substance in gas phase. Solid into gas, for example. So I'm going to use something like that as a framework for my activation, make sure that they know what all of these definitions that they need to know are. And the second part of this whole thing really is the process. How do you actually go about making a Born-Haber cycle and then applying this? And this for me is quite process driven. So whenever I see something that's process driven, I think about, okay, I need to do a worked example. So maybe between my activation and my demonstration, I'm going to use a worked example in my lesson, because I want to take bits of this knowledge through this worked example so that they can then kind of go into the demonstration on their own, maybe. So in my worked example, I'm going to be really careful as to what I'm picking for it. For example, in my demonstration, some of these students, if they get onto this aluminium oxide example, are going to need to know about the different kind of electron affinities that oxygen has. For example, in some cases, when you give oxygen some electrons, it will be an exothermic change. But then if you try giving more electrons to a negative oxygen ion, that's going to be an endothermic change. So that's one thing that I'm going to keep in mind in my worked example. Can I put in some of those finer points about electron affinities? And also, can I kind of bring out some of these points of the activation into this worked example before they go ahead and try it on their own? Okay, so there we go. That's very, very briefly how I would go about thinking about planning an A-level lesson.